video, we're going to be looking at a transformation of a tangent function. So when we're talking about sine and cosine, with some of those transformations, we saw how that affected the amplitude. But if you remember the way that a tangent function looks, so let me just draw a quick one in here. Let me get my signature yellow. Flip this around. I wish there was a way that I could just say 90. I should really explore this a little bit more to figure out if there's a way to get it at 0. There we go. Make this a little bit longer. If you remember here, we had vertical asymptotes, and I don't know why I got rid of that. I should just flip it around this way. Tried to get that 90 in there. That's good enough. So we had a vertical asymptote here at negative pi over 2, and then we had another one. I'm trying to do the same distance eyeballing at pi over 2, and then another one, pi period over at 3 pi over 2 and negative 3 pi over 2. I mean, these are not exactly the same distance. They should be. We're going to pretend like they are pi distance away from each other. Then our graph was constantly increasing. Like something like this, but a little bit better. And we repeated that over and over again. Well, what if I introduced y equals a value? Let's say I introduce some value a. I put sine, so tangent of bx. All right, so this a, remember, is my vertical stretch or compression. This was my amplitude. This is actually what created my amplitude in sine and cosine. This is going to be a vertical stretch or compression. So let's say a, in our case, is equal to 2. And I'm going to do this in a different color. Let me say a is equal to, I already used that red. I must really like that red and that blue because I keep grabbing them. A is equal to 2. What's going to happen here is when a is equal to 2, we are going to take my graph and we are going to stretch it like a rubber band. And when we stretch it, what's going to happen is that this kind of becomes a little less pronounced, and my S kind of loses that really great S shape because we're taking this and we're stretching it up. All right, or let's say that A is equal to 1/2. Well, that's a compression, which means what we're going to get a little bit more pronounced in that kind of S shape, because we're just basically taking this blue one and smushing it down from either side. So we'll get something more like that. So what we're looking at is the stretch or compression when we have the coefficient a. So we're going back to that vertically stretched or vertically compressed. Okay, so a is the vertical stretch or compression. And we're just going to say vertical scale. B, on the other hand, B is still playing into the period. So this still plays into the period. Well, this is not really our amplitude. We don't really call it amplitude. We can still use B to find our period. So if you remember, the period is equal to 2 pi over b. But in our case, our period was a little bit different. Our period didn't go to 2 pi with sine and cosine. Our period only went to pi. So we are going to reduce our period. Let's see, let's say it's 2. We're going to reduce our period to pi over b. Because our initial period is pi, then we're going to divide how many times our graph fits into that period of pi. So in this case, if my b was equal to 2, I pick that blue all the time. I even pick that blue here. Let's say my b is equal to 2. Then we're looking at pi over 2 for my period. All right, and if b is equal to 4, a larger coefficient of x corresponds to a smaller period. So again, if b is equal to 4, my period is going to be pi over 4. All right, so the graph will be compressed horizontally. So again, we're looking at this horizontal compression. All right, I'll keep it there for a second for you to all right, so the period, again, is going to still be affected by this, but our period is a little bit different than what we've seen before because our original period for tangent was pi. So now we're going to do pi over b. We're going to divide how many numbers, how many times we're drawing this guy into pi. All right. So there we go. A common error is since the function is y equals 2 cosine x has the amplitude of 2, you may think that the function y equals 2 tangent to 4x has an amplitude of 2. The tangent function, however, has no maximum or minimum values. Therefore, it has no amplitude. So again, this is not the amplitude anymore. This is called the vertical scale. All right, and this is also the horizontal scale, but again, it plays into that frequency and that period. All right, guys, so here is your tangent kind of pointing out vertical, horizontal scaling and how this plays into our period. I will catch you in the next video. If you have any comments or questions, always feel free to ask.